Welcome friends to my YouTube channel Sommo Physics. Till now I have uploaded few videos based on first chapter of thermodynamics, that is first law of thermodynamics. There in the first video I shall discuss about the first law of thermodynamics, which is basically the energy conservation law. One thing I forgot to told in that video, what are its advantages and limitations. Okay, so in the first law we have seen that whenever work is converted to heat or heat is converted to work, the amount of work done is proportional to heat absorbed. That is conversion of heat energy into mechanical work. Okay, work cannot be done at the expense of energy, and it is impossible to construct a machine that can perform work without the expenditure of energy. So this is the significance of first law of thermodynamics. Now if we tell about the limitations, then what are the limitations of first law of thermodynamics? In this law we have seen that there is a transformation between heat energy and mechanical work, but how much amount of heat energy is converted into work, that we don't tell from first law of thermodynamics. Besides this, under what condition and in which direction the transformation takes place, that we don't know from first law of thermodynamics. Okay, so these are the limitations of first law. This is one thing. And another thing that I told in previous one of the videos about various thermodynamic processes, where we see that in isothermal process temperature remains constant, in adiabatic process the entropy remains constant, in isobaric process the pressure remains constant, and in isoporic process the volume remains constant. And we also talk about another process which is known as isenthalpic process, where enthalpy of the system remains constant. For example, we took Joule-Thomson effect. Now another thing which I have to forgot, that you have to understood few terms related to thermodynamics. What are they? First of all, there is system. What is a system? A system is a certain portion of the universe that is selected for the purpose of investigation, that is within which we can perform our experiments, is called a system. There are three types of system. One is open system, where both mass and energy transfer takes place. Another is closed system, where only energy transfer takes place, not the mass. And third one is the isolated system, where there is neither transfer of mass nor transfer of energy. For example, if we take some liquid inside a thermoflux, then it is an example of isolated system. Okay, so this is the system. Surrounding, what is surroundings? Everything outside the system that can affect the system is called surroundings. Everything. So it is clear that system and surroundings constitute the universe. It is clear. Now one thing, system and surroundings, these two are separated by a boundary which is called wall, or more generally we can say the boundary, the wall between system and surroundings is called a boundary. And there may be a different type of boundaries. It may be diathermic, it may be adiabatic, it may be real, it may be imaginary, uh, there are different boundaries. Mm. Diathermic means a boundary through which heat exchange takes place, and adiabatic means through which there is no exchange of heat. Okay. Another thing I have to say that thermodynamic variable, what is it? Now, in order to represent the state of a thermodynamic system, we require few variables. These variables are thermodynamic variables, and these variables are of two types. One is extensive. Extensive variables are those that does not that depends upon the mass of the system, or simply you can say these variables depends upon the number of particles present in the system. The greater the number of particles present in the system, greater will be the mass of the system. So these variables depends upon the mass of the system. For example, volume, area, magnetic moment, heat. These are the extensive variables, and another is intensive variables. These variables are independent of mass of the system or number of particles present in the system. For example, you can take temperature, density, potential difference. Okay, these are the variables that does not depend upon the mass of the system. Okay. Another term you have to familiar is that the indicator diagram. What do you mean by indicator diagram? Indicator diagram means the diagram between any two thermodynamic variables representing the state of a system. It is a diagram which is drawn by using any two of the thermodynamic variables. For example, we know that PV diagram, temperature entropy diagram, these are the indicator diagrams. Okay, so these are the few things that you must understood before starting the first law. Okay, thank you.